So we're going to do the free response question from the 2009 Calc AP test, and this is part B, question 4. The question states, let R be the region bounded by the graph of y equals the square root of x and y equals x divided by 2, as shown in the figure above, this figure. Find the area of R. So we want the area right here. The first way to do this is to label the graph so you don't get confused later on. There's two ways to do this. You can plug y equals square root of x and y equals x divided by 2 into your calculator and find out which one is which. Or in this case, it's easier to just look at the fact that y equals x divided by 2 is a linear function, and there's only one linear function on this graph. So we use process of elimination and say this is y equals x divided by 2, which leaves this to be y equals the square root of x. The way to tackle this is to find small rectangles on the region R and add them all up. So there'll be teeny tiny rectangles and you add all these rectangles up. Zooming in, we get this rectangle. And an area of rectangle is basically side A times by side B. We can label this as side A and this as side B. To find side A, we can see here on this graph that it's basically from, let's say, we're taking this rectangle from top here to bottom here, so that's the top of square root of x minus x divided by 2. Another way to see this a bit more clearly is that we know that the square root of x goes all the way from at the top here all the way down, and that x divided by 2 comes from all the way here to here. And so if we want this length right here, we need to take this red area minus this orange area. And this red area is the square root of x, and the orange area is x divided by 2. In terms of finding the side B, we see that side B is this length right here, and that's basically the change in x, like small increments of changes. So I can simply put that as delta x. Now we want to add several of these rectangles, so I'm going to write in integral form as from start to end of this area of rectangles. So that's basically, we know it's side A times side B. Side A is the square root of x minus x divided by 2, and side B is delta x. But since we're integrating it, we can call it dx. Now to find from start to end, there are two ways to do this. Graphically, you can see that it starts out at 0 and it ends at 4. You can see the 4 here, so that's 4. Another way to do this is to solve it with equations. So you would make the function square root of x equals x divided by 2. Now if you square both sides, you would get x and x squared divided by 4.
So you would move the 4 over to be 4x equals x squared, and 4x minus x squared equals 0.
X could be 0 and 4, and we see that the 0 is here and 4 is right there. Now to integrate this, we can use the fundamental theorem of calculus, which is basically the integral from a to b of f of x dx equals big F of b minus big F of a. And so in this case, it's from 0 to 4 square root of x minus x divided by 2 dx. So we want the original function first. To do this, I like to simplify it first so it's easier for us to see. The square root of x is basically x to the power of 1/2 minus 1/2 of x dx. And to find the original function, you basically add 1 to the exponent, so 3 over 2 I'll make this a bit clearer, 3 over 2, and you take the reciprocal, multiply by the reciprocal, so it's 2 divided by 3. Because you see, once you derive this, it'll equal to x to the power of 1/2. Minus, we're keeping the coefficient, so we just put that right there. And this is actually x to the power of 1. So if we add 1 more, it'd be x to the power of 2, and times to the reciprocal, which is 1/2. Keeping in mind 0 to 4. So to make that look nicer, it's 2/3 x to the power of 3 over 2 minus 1 divided by 4 times x squared. Going to our idea about big F of B minus big F of A, we plug in 4 and we plug in 0. So if we plug in 4 in this case, 2/3, 3 divided by 2 minus 1/4, 4 squared, and we minus the function of this when you plug in 0. So that's 2/3 minus 1 divided by 4, 0 to the power of 2 squared. So that's 2/3 times, so that's basically 4 to the power of 3, and you square root that, and that's 8. So 8 minus 1/4 times 16. And we know that 0 to whatever power is 0, and 0 times whatever is 0. So this whole group right here is equal to 0. So we just leave it as that, and we just solve for that. And so that's basically 16 divided by 3 minus 4. We find the common denominator, which is 3 at the bottom, so 16. Because we have to multiply by 3 at the top, it's 12, and so the answer equals to 4 over 3. So that's part A. So we're going to continue with question 4, and we're doing part B. So once again, I'm going to just label this. And it says, the region R is the base of a solid. For this solid, the cross-sections perpendicular to the x-axis are squares. Find the volume of this solid. Basically, what it's saying is that there's this solid R as a base, and there are squares coming out. And basically, the squares add up all up together, and there are smaller squares here, and then they increase in size, and then they decrease again, because the size of the square are dependent on the length from here to here of R. So what we're going to do is we're going to zoom in and take only one square out, because we're going to add the areas of each individual square up to find the final volume. To find the area of a square, we need to do the side squared. Our question now is, what is the side? Well, what we did in part A was basically find the side A of this rectangle, and we said that the length here, or here in this graph, is basically the square root of x minus x divided by 2. And so we now know that s is the square root of x minus x divided by 2. So we're going to add all of these teeny tiny squares up to find the final volume. So we're going to integrate it. And we're doing s squared, which is the square root of x minus x divided by 2 squared. And we're going to add a dx, because remember, this square actually has a teeny tiny width here, and that can be represented by dx. We're trying to find the lower and upper limit, and we know because we're integrating with respect to x that we should look at the x-axis, and we know it starts at 0 and it ends at 4, as explained in part A. So now we're going to simplify this, keeping in mind of the rule a minus b squared, which is equal to x squared minus 2ab plus b squared. And a in this case is the square root of x, and b is x divided by 2. So once we expand it, it turns out to be x minus 2 times the square root of x times x divided by 2 plus x squared divided by 4 dx. We cancel out the 2's, and we're going to simplify this even further. So that's basically x to the 1/2, because the square root is basically x to the power of 1/2, multiplied by x, which equals to x to the power of 3 divided by 2. This is because we are adding the exponents together. And so to write this clearly, it's x minus x to the power of 3 divided by 2 plus x squared divided by 4 dx. Now we're going to anti-differentiate this. And so we know that this is basically x to the power of 1. We want to add another 1 to the exponent, that would be 2, multiplied by the reciprocal of 2, which is 1/2, minus x to the power of 5 divided by 2, because 1 plus 3 divided by 2 equals 5 divided by 2, multiplied by its reciprocal, which is 2 divided by 5, plus, we're going to keep the coefficient, so 1 divided by 4, and x to the power of 3 times its reciprocal, which is 1/3. We're going to put the upper limit 4 and lower limit 0 there. So we're going to simplify this to make it look better. Now we're using the fundamental theorem of calculus, where this is basically the same equation. We're basically going to plug in the 4 in this whole equation minus plugging the 0 in this whole equation. So here we plugged in the 4 there, subtracted by plugging the 0 in that whole equation, which is this. And we know that the whole chunk would be equal to 0. So we do all the simple calculations, and what I get is 32 divided by 60, and you want to simplify that. Divided by 2 is 16 divided by 30, and you want to divide both the top and bottom, divide by 2 again, which is 8 divided by 5, and that's your answer.